Good afternoon. My name is Valanathan Munsami, and I'm the Chief Executive Officer of the South African National Space Agency. And I'm really excited to be at Africa Tech Week. I'm going to be speaking around igniting the space economy and its collateral benefits. So the narrative is essentially going to flow from the importance of space science and technology from a governmental perspective and see how that filters down into the actual applications itself and look at it from an African context as well. So any national government that's worth its salt is looking at two key priorities at the highest level as national key priorities. The first is the quality of life of its citizens, the well-being of its citizens. The second is around wealth creation. So when we talk about socio-economic development, these are the two priorities we're essentially talking about. Wealth creation, which is the economic aspects, and the quality of life, which is the social aspects. So what government has to do is find a fine balance between these two aspects that it needs to focus on from a policy perspective. But in so doing, we have to look at reforms or transitioning into different economic spaces. So where we are in South Africa at the moment is we are transitioning from a resource-based economy, primarily focusing on our natural resources like mining, agriculture, and so on. But we're transitioning towards what is called a knowledge economy. So in a resource-based economy, you essentially mine and harvest these resources. But much of that goes out of the country and we re-import the finished products. So the value proposition actually happens outside of the country. So with the knowledge economy, we're looking at changing that picture of ensuring that that value proposition is actually done in the country, the economic rent and the profits are actually realized in the country. So the capital outflows is minimized. And that obviously fuels the economy and it fuels the social aspects that government is trying to deal with. So when we're looking at science policy and research and development perspectives in terms of how we're fueling and sustaining and supporting research and development into the country, we're looking at how does it connect with and drive the knowledge economy. So that's the whole aspects and the policy drivers geared towards the knowledge economy. So let's look at the advantages of what satellites provide. Essentially, they provide what is called a synoptic view. Effectively, that means that if you're looking at a land mass, you have a high-level view. So the satellites are normally between 400 and 600 kilometers above the Earth's surface. So you don't see national boundaries. In fact, your viewpoint transcends national boundaries. So that's very important. For example, if you're looking at in the environment, the flow of rivers that cross national boundaries, climate change as an example is not limited to national boundaries. So that synoptic view has very much the potential of viewing problems from a much broader lens as opposed to just viewing that from the ground perspective. It also provides what we call systematic coverage. So essentially the satellite comes through over the Earth when it's in orbit, it comes through at the same time every day. So we call that a sun-synchronous orbit. So effectively, if a satellite is coming through at 9 o'clock today, it'll come through at 9 o'clock tomorrow and the day after and so on. So that's very convenient because then you can compare one satellite image today to the one tomorrow and the day after. And if you're looking at the same landscape, you can see any changes. So we call that change detection. And that can also allow you to ring the alarm bells if you see there's adverse changes happening in the landscape. And lastly, also in terms of the payloads that we put on the satellites, they actually allow us to see things that you and I cannot see. So let's look at it from an Earth observation point of view. So what we see here is the sun is illuminating the landscape. And in this case, you see a tree. So the sun is hitting the tree with photons, and that is reflected off back into space. So as a satellite comes by, it's picking up the photons that are reflected off the tree surface. But if you go to a micro level, essentially the sunlight has all parts of the spectrum. It's white light, essentially. But at the micro level, what's actually happening is the blue and the red part of the light is actually absorbed, and the green part of the spectrum is actually reflected. So that's how you see the tree as being green. And so the photons that are being collected by the satellites is essentially in the green part of the spectrum. And this is essentially in what we call the visible part of the spectrum. Now, don't be alarmed with this particular graph, but with that particular application that I just gave you, you will notice that in your bottom left-hand corner, that little blip at the bottom left-hand corner is essentially what you and I can see. Everything on the right of that blip is in the infrared part of the spectrum. You and I cannot see this with our naked eye, but the satellites pick up this information. And this is the kind of information which is very rich in the infrared part of the spectrum that you and I cannot see, but is used for what is called precision farming. So the utility of Earth observation and the value of satellite platforms is incredibly powerful. I've just given you one application. There's a whole myriad of applications. So if you go into the actual field itself and you look at the satellite image, and you can verify, and this is where we do field trips to actually validate and verify the satellite imagery. And once you do a series of these validations, you can then use that in terms of mapping, understanding it from an artificial intelligence point of view. So you can then classify this particular image on your left-hand side, just using artificial intelligence in terms of what you've validated on the ground. If you look at it from a satellite communications point of view, essentially a telecom satellite is sitting around 36,000 kilometers above the Earth's surface. And so most of us have DSTV or digital TV at home. And essentially what is happening, so if you think of watching, let's say, soccer or Formula One live, essentially what's happening is the signal is being broadcasted from one end of the Earth, is transmitted to the satellite, and the satellite is transmitting it back towards Earth. This is the value of satellite telecommunications. Its reach is beyond even the cellular networks that we know. For example, you can reach even the very rural communities with this kind of platform. So what has the application got to do with government departments? So in 2007, we sat down and we asked all the government departments back then, what is it that you want from the space agency if we had to set up a space program? And that was a question we posed to them. And the outcome of that was 3 sets of clusters. So the first one is environment and resource management. So this is what government departments said, we would like you to assist us in terms of applications. So environmental and geospatial monitoring, ocean, coastal and marine management, land management, rural development and urban planning, topographic mapping, hydrological monitoring, climate change mitigation and adaptation. And by the way, you cannot do climate change without space technology or satellites. 60% of the essential climate variables come from space. And meteorological monitoring, that's your weather patterns and so on. The second cluster was health, safety and security. So if there's disasters, you look at disaster monitoring and then relief, hazards forecasting and early warning, like you can calculate floodlines as an example. If you know the amount of precipitation that's coming through, you can calculate which areas will be flooded based on satellite technology. Cross-border risk, the flow of assets across the border using navigation applications, disease surveillance and health asset monitoring, regulatory enforcement, defense, peacekeeping, and treaty monitoring. So you see the scale of applications is quite extensive when you're using satellite applications. Innovation and economic growth, tourism and recreation, communications, space science and exploration. A big part of what we're trying to do is also stimulate the industry. So space technology transfer and spin-offs, and also development of the space industry. And this is where we are trying to, as a space industry, as agency, trying to bring the industry into the value chain, where we are actually starting to contract the industry rather than implementing things in-house. So stimulation and support of the industry is quite key to what we do inside of the agency. Because this is Africa Tech Week, I thought I'd just give you the African perspective as well. And what's interesting, if you look at this particular map, Africa covers 20% of the Earth's land surface, and it accounts for 15% of the world's total human population. Now, if you look at all the countries and the regions represented in green, the US, India, Europe, China, Argentina, if you take collectively the land masses of all of these countries and regions, in total, they come to just over 30.2 million square kilometers. The land surface of Africa alone is 30.3 million square kilometers. It's actually greater than the sum of all of these regions and countries. And that tells you that the scale of the environmental issues that we're looking at is way bigger than any of these countries put together. And what you find very interesting is that what Africa spends on space technology is insignificant versus what these countries. The US, for example, alone spends $40 billion per year. And in Africa, I think we're not even reaching $100 million. So you have to look at it from the disparity point of view in terms of developing countries versus developed countries, and how much we're actually spending on technologies that gives us insight into our environment and so on. And just to give you a sense, I'm not expecting to read all of this, but this is showing you within the African Union, you have 8 commissions, African Union commissions. And what I've just put down here is the objectives of each of those unions or commissions. And I put a tick box essentially to say that you actually need space science and technology to deliver on this particular objective. And if you do the sum of the 40 objectives in total, 35 of those require the use of space applications. In effect, 90% of the work of the African Union is reliant on space applications. So where are we going with this conversation currently? So SANSA in the last few months has been able to secure just over 4.5 billion rands that we will be spending in terms of strengthening our infrastructure. So what this would mean, if you follow the value chain from the top right, we will have a suite of satellites that we will be building. We will be contracting our industry who has this capacity and capability. And so we will put into orbit a number of these satellites. We'll then beef up our ground segments. We'll have a new ground segment. And in fact, this ground segment is also being positioned in conversation with NASA for the deep space network. So NASA is going back to the moon and to Mars, and it requires a ground segment that talks to the various spacecrafts on the way to these various missions. So we're looking at hosting the 4th deep space network. So there's one in Australia, one in Spain, and one in the US. So the 4th one, if it's approved, will be here in South Africa. And that will see 4 34-meter diameter dishes in a place called Fontaine in the Western Cape. And so we're hoping that this will be up and running and the green light will be given fairly soon. So we're actually building a new ground station in Fontaine. That will essentially be able to talk to some of these satellites. So as the satellites pass by, we actually communicate with the satellite to look at the housekeeping in terms of the batteries and whether the electronics are functioning okay. And then you also bring the data back down. So as the satellites pass through, you download the data. Now, once you've downloaded the data, you then push it through into the data segment. So here we're looking at setting up a new capacity in terms of cloud storage and processing. And there are some new technologies that we're bringing in. So we have data archive that extends right back to 1972. So we bring in a system called a data cube. And what this helps us do, if you had to look at any particular location in South Africa since, let's say, the 1970s and up until the present day, if you had to look at that series of satellite imagery, it could take you up to 6 months to actually process those satellite images. But what the system is doing that we are producing or establishing at the moment is it's packaging the pre-processed data in such a way that that processing will take you 3 hours as opposed to 6 months. So we're finding a very convenient way, given the big data and the 4th industrial revolution, and including artificial intelligence, is to streamline and ensure that the processes are much more efficient than we are used to. So that will give government departments the answers they're looking for much quicker. And in that particular value chain, we're also bringing in the industry. But at the end, we also want to produce those products and services. That essentially defines the success of a space program, whether we're actually able to deliver on the products and services to the various government departments. And in this domain, we're speaking to what is called the district delivery model. So the new administration has essentially come up with the focus on the district delivery model. So there's a number of districts that we have to push government services into. And so that's where we're looking at from a public goods perspective, even a commercial perspective, is to pull through the value chain that data, repackage it into information and put it down into the ground where it can actually be used. And in terms of the actual expenditure along that value chain, about 75% of the cost is around the satellite segment. It's a very expensive undertaking. 8% is on the ground segment, another 8% on the data segment, and another 8% in terms of producing those products and services. So now you can see the economy in terms of us contracting the industry So through this, we're building small, medium enterprises. We're looking at transformation of the issues. So there's all sort of policy instruments that we'll be introducing in terms of how we procure some of these services. And at least 1% of that is on human capital development. So at the moment, we train and support about 50 master's and PhD students in space science and technology. But what we're looking at upping that investment in the next few years to get more people into the system as the system starts to grow. And this is my final slide, because all of what I've just said, we now have a new 5-year strategy for the space agency. And if you look at our vision statement, it's essentially moving us from a focus at a national level to now an African continent perspective. So what we're looking at is an integrated national space capability. That means that SANSA is responsible for a space ecosystem and stimulating and supporting and developing and strengthening that ecosystem. So it's not upon SANSA to implement all of these activities, but actually contract the implementation to industry. So that's the economic aspects in terms of stimulating the industry. And in so doing, we're hoping to respond to the socio-economic challenges in Africa by 2030. Now, 2030 is very important because you have the Agenda 2030, the Sustainable Development Goals, and the National Development Plan, which extends to 2030. But Africa has also adopted the Agenda 2063, and that usually moves in 10-year chunks. So that will conveniently take us up to 2030 in the first 2 phases, essentially. So we kind of geared up to align ourselves with all of the policy instruments as well. From a mission perspective, given the fact that we are supporting the broader ecosystem, what we will do from a SANSA perspective is provide that leadership in unlocking the potential. As I said, it's about supporting the ecosystem rather than us doing everything in-house. So this is where we're now stimulating the economy and bringing the industry into the value chain. And obviously by doing that, we want to see the potential for advancing and realizing the benefit of space science and technology to humanity. I thank you for your kind attention.